Hello my dear students, once again I am here as we are doing chapter number 17 continuity. We have finished few of the questions in my previous video. Let us start from there only. We are going to start question number 7. What question number 7 is saying? Discuss the continuity of a function of the given fx is equals to fx is given as modulus x minus 1 plus modulus x minus 2 at x is equals to 1 and x is equals to 2. Now, x is equals to 1 and x is equals to 2. We will have to check the continuity of this function. So first of all, we will have to describe this function. We will have to write this function. So x minus 1 and x minus 2 both will be negative when x is less than 1. So minus x minus 1 minus x minus 2 when x is less than 1. And when x is more than 1, then x minus 1 will be positive. But when x is less than 2, x minus 2 will remain negative. In this case, x minus 2 will remain negative. So x minus 2, and when x is more than 2, more than equals to 2, then both of them will be positive. So this way, this will be the definition of this function in modulus, that when x is less than 1, both of them will be negative. When x is more than equals to 1 but less than 2, x minus 1 will be positive, x minus 2 will be negative. When x is more than equals to 2, then both of them will become positive. So we can define it once again. Fx is equals to minus x plus 1 minus x minus 2, so it will become minus 2x, and here it is plus 1 and here it is plus 2, so it is plus 3. Minus 2x plus 3 in the case when x is less than 1. X minus x, then x and x is cancelled, so value is plus 1 when x is greater than equals to 1 but less than 2, and the value is 2x minus 3 when x is greater than equals to 2. Now we will have to check its continuity at x is equals to 1 and x is equals to 2. So LHL at x is equals to 1. So limit x tends to 1 minus, that is fx is equals to limit h tends to 0 f1 minus h. So 1 minus h, in 1 minus h case the value of the function is this. So in this, in place of x, let me substitute 1 minus h. Limit h tends to 0 negative 2 1 minus h plus 3. If I am substituting h as 0, so this will become 0. Negative 2 positive 3 is giving me positive 1. This is the value of left hand limit at x is equals to 1. Now RHL at x is equals to 1. So limit x tends to 1 positive function. So limit h tends to 0 f1 plus h. So limit h tends to 0. When value of the function is between 1 plus h, so the function is 1 and hence we got the value as plus 1. Similarly, the value of fx, that is f1, is also 1. So we can say limit x tends to 1 negative, that is left hand limit, right hand limit, and the value of the function is equal. So function is continuous at x is equals to 1. Similarly, we will check it for x is equals to 2. LHL at x is equals to 2. So limit x tends to 2 negative, fx limit h tends to 0, f2 minus h is equals to, where we'll have to keep it, 2 minus h. It is less than 2, so it is here. between when the value of x is less than 2, it is 1. So limit h tends to 0, 1, that is positive 1. Similarly, I can get it RHL at x is equals to 2. So limit x tends to 2 positive fx. I'll get it limit h tends to 0 f 2 plus h. Into case of 2 plus h, the value of the function will be 2x minus 3. So in place of x, I'm going to substitute 2 plus h. So limit h tends to 0, 2 into 2 plus h minus 3. If h is 0, it becomes 4 minus 3, that is 1. And f2. So when function is 2, the value of the function is this. So 2x minus 3. In this, I am substituting x as 2. So here also 4 minus 3, the function is 1. So I got limit, left hand limit at 2, right hand limit at 2, and the value of the function at 2 is equal. So we can say that function is continuous at x is equals to 1 as well as at x is equals to 2. So fx is continuous at x is equals to 1 and at x is equals to 2. So this was the solution for question number 7. Now look for question number 8. In question number 8, he is asking the value of unknown. Determine the value of k for which the following function is continuous at x is equals to 3. So function is given continuous already. Now you will have function is continuous, it means the limit of the function and the value of the function is equal. And by that we will get the value of it. What the question is? Question number 8. fx is given as x square minus 9 upon x minus 3 when x is not equals to 3 and k when x is equals to 3. Okay, and since the at x is equals to 3 fx is continuous. So if fx is continuous, it means limit x tends to 3 fx is equals to fx. This is the condition for continuity. Now limit x tends to 3 fx is equals to f3. So what is the value of the function? That is x square minus 9 upon x minus 3. X tends to 3, x square minus 9 upon x minus 3 is equals to f3 is k. Now solve it. If we will solve it, we can solve it by identity method, factorization method. So we got x minus 3, x plus 3 upon x minus 3. X minus 3 is cancelled, and when we are substituting x as 3, I got 3 plus 3 is equals to k. So k is equals to 6. This way the value of k is 6. Similarly, we are having the next question, that is question number 9. In that also we will have to find out the value of unknown, and once again the this function is given continuous. Let us see that. This is, we are doing question number 9. Function is given as x square minus 2x minus 3 upon x plus 1 when x is not equals to minus 1, and when x is equals to minus 1, its value is given as lambda. And the function is continuous at x is equals to minus 1. Function is continuous. So if function is continuous, what will happen? Limit x tends to minus 1, fx will be equals to fx. Then what will happen? Limit x tends to minus 1, fx will be equals to f minus 1. The value of the function is this. So this we will solve once again by factorization method. X square minus 2x minus 3. As you can see, in the present situation it is 0 upon 0. that is lambda. So we will factorize the numerator. Limit x tends to -1, we will get x plus 1, x minus 3 upon x plus 1 is equals to lambda. X plus 1 and x plus 1 is cancelled. In place of x, if I will substitute -1, then I'm going to get lambda as -4. So that will be the value of unknown here. This is question number 9. The same thing is happening in question number 10, 11 and 12. Let us solve few of them. What has happened in question number 10? 10 you can do. Let me solve question number 11 and 12. Okay, question number 11. What is happening in question number 11? Fx is equals to log 1 plus ax upon x. 1 plus ax upon x, and upon x is for all, minus 1 minus bx upon x. Oh, there also it is written log. Okay, what the thing is, both of them are having log and x is upon all. Log 1 plus ax plus or minus minus log 1 minus bx upon x when x is not equals to 0, and when x is equals to 0 the value of the function is k. So once again you will have to find the value of k when the function is continuous at x is equals to 0. So when the function is continuous, limit x tends to 0, fx will be equals to fx, and limit x tends to 0, the value of the function is log 1 plus ax minus log 1 minus bx upon x is equals to k. Then I'll have to find the value of this. So what I am going to do, limit x tends to 0 log 1 plus ax upon x minus, I have divided x with both of them, limit x tends to 0, 1 minus bx upon x is equals to k. What I have studied, that log 1 plus x upon x is equals to 1 at limit x tends to 0. So what I will do, I will use this formula. So for this purpose I want ax here. So but here it is x only. So what I'll do, I'll multiply and divide by a. Here I want b minus bx. So I will multiply by minus b and multiply it by minus b. So I will get a limit x tends to 0 log 1 plus ax upon ax. That minus b will make it positive. B limit x tends to 0, 1 plus minus bx upon minus bx is equals to k. The value of this function will be 1. Similarly, the value of this function will also be 1 is equals to k, and in the end I am going to get k as a plus b. Okay, so this was question number 11. On the same way concept we are having question number 12. What question number 12 is saying, that the function is given, and if this is continuous at x is equals to 1, find the value of a and b. What is the function? Fx is given as 3ax plus b when x is more than 1. Its value is 11 when x is equals to 1, and it is 5ax minus b when x is less than 1, and at x is equals to 1 fx is continuous. Okay, if fx is continuous, its left hand limit, its right hand limit will be equals to fx. Okay, so first of all let me calculate the left hand limit. LHL at x is equals to 1 So limit x tends to 1 negative, that is fx. Limit h tends to 0, f1 minus h. Now 1 minus h means I'll have to substitute 1 minus h. The value of the function will be this. Here in x I am going to substitute 1 minus h. So limit h tends to 0, 5a1 minus h minus b. If h is 0, it will become 5a minus b. The value of left hand limit is 5a minus b. Similarly, I am going to calculate RHL at x is equals to 1. So limit x tends to 1 positive, that is limit h tends to 0, f1 plus h. Now 1 plus h, it means the value of the x is more than 1. So in that case, I will take the value of the function this. So limit h tends to 0, 3a 1 plus h plus b. If h is 0, I got the value as 3a plus b. And the value of fx, that is f1, is given as 11. And since the function is continuous, so limit x tends to 1 negative, that is left hand limit, right hand limit, and the function will be equal. So 5a minus b is equals to 11 and 3a plus b is also 11, and that's why we got, I have written something wrong. Yes, what is wrong? That 5a minus 2b it is. So it is minus 2b. I got it 2b. Then I'll have to multiply it by 2. So 5a minus 2b is equals to 11, and 6a plus 2b is equals to 22. On adding, we got 11a is equals to 33 and a is equals to 3. If a is equals to 3, then let me substitute it here. 9 plus b is equals to 11, and hence b is equals to 2. So this way our first exercise for continuity is finished, and now I will look for the second exercise in the live class, so that this of our chapter will be finished on Thursday. Till then, finish off your work and take care of yourself.